then I would go for paper voting instead of getting some credentials and messing with that. So the efficiency of internet voting in Estonia is that you won't need any other registration. If you are registered with your place of living, you are eligible, and you're having ID card, you're eligible to vote. Right. Well, this is what it says. Well, the problem here is that not many people have been using the ID card electronically because there are not many reasons for using it. Average people, they don't sign papers very frequently, maybe 1-2 times a year. And the other systems are accessible by other means. I mentioned the internet banking codes and stuff like that. And therefore, not many people have a smart card reader at home or at work. Well, I can estimate there are maybe some 20,000 smart card readers installed, which actually covers pretty much, but still. So there is no reason to buy that. So that's why not many people voted electronically. And system required smart card reader. It supported. It still supports these 3 operating systems. Basically, that's all you need. So how it goes is that you go to the correct website, then, well, this is illustrative, very nothing to do with the real thing. And enter pin 1, smart card reader, and you will be immediately recognized because where do you, constituencies, where do you elect, who you are, and what are your candidates. So basically what you do is you just select a candidate and press vote and enter a PIN for digital signature, and you actually go through. So it takes like 12 seconds. So compared to going to some polling station in the winter time through the snow and wind, well, it's somewhat easier. Well, how it works, it's very basic scheme is here. It shall explain pretty much everything. What it is the notion of double envelope, which is actually known from paper world as well. If you go to somewhere not in your hometown in pre-election days, you will be given chance to vote in a way that you seal your vote in a smaller and anonymous envelope. And then this envelope you put in the bigger envelope and wrote your address in there and your ID code. And based on that outer envelope, it's transported to the proper polling station, and it's opened, and then you are registered that you have voted, and the inner envelope, which is anonymous, is put into the ballot box. Well, this works in the very same way. So when the voter makes his choice, this choice will be encrypted with the public key of the system. And then this encrypted vote is signed by the voter, which makes it personal. And it happens all before this vote goes to the network. It happens in the local computer. So this vote will be sent to the central place, okay, central server, and then you can see that if this guy has voted before, you throw away the previous votes, for example, and if it needs to be cancelled for some other reason, you can do that. And before counting the votes, these outer envelopes, the personal data, they are removed. and the, so to say, the voting vote counting machine accepts only these anonymous encrypted votes. So there is not loss of privacy here. And of course, they are counted in results output. Well, this is very rough scheme of the architecture that's going on here. So we have something like a voter application on the user's computer, which takes care of this encryption and digital signing. Now we have just vote forwarding server here. This is the web server you talk to. And this forwarding server doesn't actually save these encrypted votes. It sends it back to the vote storing server. Okay. So there is no direct access to the database of the casted votes. And before counting this, of course, which takes place offline, and these votes, anonymous votes, are transferred to the application through the with the external media. Of course, the principles building this system was that every transaction, every move is logged heavily, and there are special means for verifying these logs to see whether they are consistent with each other or not. So you can actually track what happened with the vote from server to server. So you can actually see whether your vote was actually taken into account or not. But of course, you cannot see which vote it was actually. About the technology, yes. The trick here was that, first of all, you gather every guy in a city or in a country who could speak out on a topic and take them all to the sauna and let the ideas flow. So basically, in various stages of the development of the system, there were, building a concept, then security analysis, and so on. We put together different teams of people who could influence the development of the system. Simplicity, of course. Everyone could, yes.
I have a quick question from a security standpoint. I understand you said there are plenty of logs once the vote reaches your system, logs between the servers. But for me on the user end, if I'm voting on my home computer, 80% of computers have spyware and malware installed. So how do I know that I am actually voting for who I think I am? How do I, as a user, know that I'm on a computer that I can trust? I mean, if I have an Internet Explorer plugin that instead votes for candidate B instead of candidate A, but shows me candidate A, how can I verify my vote?
Yes, that's a good question, because you can never be sure with internet voting. It's evident that the weakest link here is a computer of the voter, and the actual threat you can do is actually to write such kind of, there is this voter application. If you replace that, okay, which would behave that disregarding what you choose, it just casts the wrong vote. Well, you cannot actually fight with that. What you could do, what we did is of course, we were publishing the MAC codes of the software, publishing the instructions how to verify whether this software is authentic or not, and then to pray and see whether there will be an attack. What we did was that, okay, we come to that. From an operational point of view, it was very, very challenging. But it's definite that you cannot fight with this threat as long as we talk about PCs and internet as of today. Okay, what it says is that keep it as simple as possible, use the stable platforms, well-known tools, nothing fancy. And the reasons are evident. To keep it as simple, to be auditable, understandable, auditable, checkable. Okay. This is actually what was related to that question. The procedures. All the actually use cases in a procedure of setting up the voting, launching it, finishing it, counting the votes, all the procedures were very accurately and fully documented. And 2 months before, before the election day, we started the courses with the auditors. We used KPMG auditors and invited all the political parties to participate on this kind of crash course. For them to understand, we wanted to have observers, we wanted to have auditors, but it's extremely difficult for some political guy to understand what's actually going on. So what we had is this kind of courses. We explained during a month, twice a week to them how it's built, where is which document, what they should read, what they should understand, what they don't want to understand, and so on. Yeah, and we also were very cautious with these procedures, critical procedures. We videotaped everything. In case someone would question the procedures or correctness, we could prove something. Now also we put together a team of security, IT security experts who actually are operating on some banks, some bigger telecoms, some other institutions. We had a networked team to monitor the activity, what's going on a Estonian internet, so to say, what kind of attacks there are. Is there anything which we could suspect as being related to the internet voting system, targeting it? So we monitored every virus before and during the internet voting period. About physical security as well, it was a lot of fun. A lot of policemen distrusting each other. And yeah, we gave up with the idea to use some telecom operator or commercial operator, and instead of that, we pick up the police, actually, which have very advanced hosting facilities available, plus physical security in terms of, uniforms. And of course, one thing to mention is that that sealing of various things for just preserving the evidence that nothing was changed or something was authentic was used and nothing changed in between. That sealing of hardware and also sealing of pieces of information stored on CDs, and so it was very, very important. Well, this is just one picture from the statistics. Maybe the fun part here is that in which time people vote. First, they get to the working place, and then they come home. So from this perspective, even it seems that peak